Welcome to Session 3. Today we meet two special pairs of angles that show up on the GED all the time: complementary angles and supplementary angles. These pairs are powerful because of one simple idea. When two angles add up to a fixed total, knowing one of them instantly gives you the other. So instead of measuring, you just subtract. By the end of this lesson, finding a missing angle will feel almost automatic. Here are the two rules side by side, and they're beautifully simple. Complementary angles are two angles that add up to 90 degrees. Supplementary angles are two angles that add up to 180 degrees. That's the whole idea. Two angles that combine to a fixed total. 90 for complementary, 180 for supplementary. Everything else in this lesson is just applying these two facts. Now, these two words are easy to mix up, so let's fix that with a memory trick you'll never forget. Complementary starts with the letter C, and C is for corner, a 90-degree square corner. Supplementary starts with the letter S, and S is for straight, a 180-degree straight line. Corner is 90, straight is 180. So the moment you read the word, the letter tells you the total. C, corner, 90. S, straight, 180. Let's find a complement. Two complementary angles fit together to make a right angle, a perfect 90-degree corner. So if one of them is 35 degrees, the other must fill up the rest of the 90. We take 90 minus 35, which gives us 55 degrees. Let's check it. 35 plus 55 equals 90. Perfect. Notice the method. To find a complement, you always subtract from 90. Now a supplement, which works exactly the same way, just with a different total. Two supplementary angles sit together on a straight line, forming 180 degrees. So if one of them is 110 degrees, the other is 180 minus 110, which is 70 degrees. And let's verify. 110 plus 70 is 180. To find a supplement, you subtract from 180. Same idea, bigger total. Sometimes the GED won't hand you a plain number. Instead, the angles are written with a variable, and we set up an equation. Let me show you how clean this is. Suppose one angle is 3x, and its complement is x plus 10. Because they're complementary, they must total 90. So we write 3x plus the quantity x plus 10 equals 90. Combine like terms to get 4x plus 10 equals 90. Subtract 10, and 4x equals 80. Divide by 4, and x equals 20. But we're not done. Always plug back in. 3x is 60 degrees, and x plus 10 is 30 degrees. And 60 plus 30 is 90. Let's ground this in the real world. Picture a board cut at an angle to lean against a wall. That cut creates two angles, the angle of the cut itself and the angle the board makes with the floor. Very often, those two angles are complementary. They add up to 90 degrees. So if a carpenter measures one of them, the other comes for free by subtracting from 90. This is exactly why these angle pairs matter. Here's an important idea that surprises a lot of students. Complementary and supplementary describe the sum of two angles, nothing more. The two angles do not have to be touching, and they don't have to share a side. A problem might show one angle on the left side of the page and another all the way on the right, and simply tell you they are supplementary. That's completely fine. As long as the two measures add to 180, the rule still applies. Don't let separated angles fool you. Let's check your understanding. Two angles are complementary, and one of them is 35 degrees. What is the other? Since the word is complementary, the total is 90. Remember, C for corner. So we compute 90 minus 35, which gives us 55 degrees. Let's recap. Complementary angles add to 90. C for corner. Supplementary angles add to 180. S for straight. To find a missing angle, just subtract from 90 or from 180. And when the problem uses a variable, set the sum equal to the total, solve for x, and always substitute back to find the actual angle. 2 rules, 1 subtraction. Nicely done on Session 3. You can now find complements and supplements with confidence, whether the angles are given as numbers or as expressions. Next time, we'll look at what happens when two straight lines cross each other and discover vertical and adjacent angles.